What's up, Algebra 1 students? Mr. Ford here with another homework tutorial. This is for 3.3.2 Part 1. Problems 93 through 98. We're going to start with some absolute value equations. So these aren't going anywhere. They're good to get used to solving them over and over again, too. Here you got the absolute value of x equals 7, which is pretty simple. It only has two answers, x equals 7 and x equals negative 7. Both of those numbers have an absolute value of positive 7. Question B takes it a little bit further. Now you got the absolute value of 2x equals 32. The best way to do this is to split it up into two problems. 2x equals, 2x equals. One of these will equal 32. The other one will equal negative 32. That's the way it's done. Now you can solve both of them by dividing by 2 on both sides, and that will give you both of the solutions. X equals 16 and x equals negative 16. There you go. Next question we got is question C, where the absolute value of x plus 7 equals 10. Again, this is going to be solved the same way. Take that inside part, x plus 7. You're going to write it twice. X plus 7 equals and x plus 7 equals. One of these will equal 10. The other one equals negative 10. That's the same pattern every time. The more you can get used to it, the better. So you get the same x plus 7, 1 equals 10, 1 equals negative 10. Okay, now we're gonna subtract 7 from both sides in both equations, and we'll get our two solutions. One is going to be x equals 3, the other one's going to be x equals negative 17, and there we go. Pretty cool. Finally, we got question D, which is basically the same as question A, only instead of a fun number, we have a weird, obscure number, but it's going to be the same idea. Positive 53.1 and negative 53.1. Pretty simple. All right, question A. Solve each equation, 394. Solve each equation below for the indicated variable. So this is what we're doing new today in class. What we're going to do here is we're not actually going to get an answer for this problem. We're going to get x equals for the answer, and we're going to have some other expression over there. So the idea is to target the x and get rid of everything that's not x. Let's start with this minus 2y. We can do this by flipping the 2y over to the other side, and that gives you 3x equals 18 plus 2y. Now, again, we still got to get x by itself, but if we divide by 3, that will cancel out the 3 that's there, and that'll be the answer. And it's not a very nice answer, but 18 plus 2y over 3 is pretty good. It's not, I mean, that's pretty good. I guess if you wanted to, you could divide both 18 and 2y by 3, and you could call it 6 plus 2y over 3. That would work too, but I mean, I don't think that's necessary. Question B, the objective is very much the same in this problem. Now we're solving, I think, is that the same equation? 3x minus 2y? It is the same equation. Now we're solving it for y. So we're going to kind of do the opposite. We're going to start by subtracting the 3x, so we'll move that over to the other side. Just like algebra tiles, we're basically flipping the 3x over to the other side. We're going to have negative 2y equals 18 minus 3x. And now we're going to divide by negative 2 this time. This will cancel out. You'll have y equals 18 minus 3x over negative 2. And that is as good an answer as anything else. And again, you could divide that negative 2 out. You could call it negative 9 plus 3 over 2x if you wanted to, but that's unnecessary. Just call it a day at that point. Question C, r times t equals d, but we're going to solve this for r. And this is actually pretty easy to do. All you got to do is get the r kind of alone. So we're going to divide the t on both sides. Just like that. It's going to cancel out over here, and r will equal distance divided by time. This is referencing rate, which is a rate or a speed is calculated by doing distance divided by time. Question D, circumference equals 2 pi r. This time again, we're going to be solving it for r though. So we're going to get rid of everything that's not r, which would be 2 and pi, which we're going to divide by at the same time because we're smart. We're going to divide by 2 pi. Again, what's going to happen is that 2 pi divided by 2 pi cancels out, and we get r equals c over 2 pi. And that's the one. Next, we got a bunch of rational expressions here in 395. This is a checkpoint quiz coming up in a couple days over this exact concept, so we should get used to seeing plenty of it going forward. The trick with this question right here is that they're already got the same denominator. That's even nicer. But we should convert these into improper fractions first. Let's start by doing 9 times 3 is 27. 27 plus 2 is going to give us negative 29 over 9. 9 times 8 is 72. 72 plus 7 is going to be 79 over 9. And now we can just add those two numbers together. Negative 29 plus 79 is going to give us 50. 50 over 9, and I would circle that and call it a day. I don't think it simplifies at all anyway. Question C, you got a subtraction problem here, but now we have different denominators. This one's going to take a little bit of space, I think. Let's start by doing 7 times 7 is 49. 49 plus 2 is 51 over 7. Minus 5 times 4 is 20. 20 plus 1 is 21 over 5. And let's make that a negative out in front there, too. Now, we can't actually subtract this right now because neither of these two numbers, the denominators, are not the same. So we have to make them the same by multiplying by 1 with both fractions. 7 and 5 are both prime numbers, and they're odd. So the first number they're going to have in common when it comes to multiples is 35. So that means we're going to multiply the left fraction by 5 over 5 and the right fraction by 7 over 7. I'm going to do a lot of mental math for this problem because I don't have Calculator Cam active right now. I know it looks like I do, but that's actually an old image. Anyway, 5 times 51 is going to be 255. That's negative still, over 35. 21 times 7 is going to be, let's see, 140 plus 7. It's going to be 147 over 35. And then we got negative 255 minus 147. Holy beans. I'm actually going to stack these up and subtract it over here. Let's see. Actually, since they're negative, we're actually adding these numbers together because they're heading in the same direction, so we're going to add them. 5 plus 7 is 12. That's going to be a 0. It's going to be a 402. So we're going to have negative 402 over 35, and God help us if that simplifies. I don't care. So that's that. That's a terrible question, but hey, that's the way it goes. Question G. 7 times 1 is 7, plus 5 is 12 over 7, times 7 times 3 is 21. 21 plus 6 is 27 over 7. Now we're multiplying. Actually, I'm going to get a calculator. Am I within arm's reach of one? I am. Beautiful. And I could probably even get Calculator Cam up and running without too much trouble here, too. Hey, cool. I think I got it. Look at that. Look at us go. We're geniuses here in this class. So smart. So smart. Okay, Calculator Cam up and running. I'm going to make it a little bigger here on this screen so you can see it. What we're going to do here is we're going to multiply 12 times 27. That's going to give us the 324 we require over 49. When you're multiplying fractions, you're allowed to just work straight across there. 324 divided by 49 is going to give us that number. A little cool pro tip, if you push the math button at this point and then select that command, arrow frac, from the list, that will take whatever input you give it and make it a fraction. Looks like it doesn't get any better than 324 over 49, so we're going to move on. Down here we got a division problem. First thing is that 7 times 8 is 56. 56 plus 1 is 57 over 7. And we're going to divide that by 9 times 5 is 45, and 45 plus 5 is 50 over 9. When you're dividing fractions, the best way, there's a lot of reasons why this rule works, but I'm just going to tell it to you. The best way is to change division into multiplication and then flip this fraction to 9 over 50. And that's it. Now, 57 times 9 is not a nice number, 513, negative 513. And 7 times 50 is going to be 450, I think. 350. I can't do math in my head. Again, I don't know if this fraction divides out anything nice. It probably doesn't. 513 divided by 350, I feel like it might, though. It doesn't, so we're going to call that the answer right there. Wow. Those problems are not fun. The ones on the test are not as bad as those ones, I think, but they're coming up. Next question, we're getting back into the past a little bit here. We're going to find the equation of the line described below. We're looking for a line with a slope of 0 that passes through the point 6, negative 11. This is actually insanely easy to do. Remember, the key is y equals mx plus b here. So a slope of 0 means that m is 0. And it means that it has to go through the point 6, negative 11. So if I was going to put all this information into mx plus b, I would get negative 11 equals 0 times x plus b. And that means that b, since 0 times 6 doesn't really matter, b is negative 11. And so your equation ends up being something like this. Y equals 0x minus 11, which we would never write. We would write y equals negative 11. And that's it to do. Simple. I mean, a horizontal line that goes through negative 11 is all you need to know there. Question B is going to be a little more involved, a line that passes through those 2 points. We first need to know the slope. So let's go ahead and use the slope formula. Let's start with 6 minus 12, which will give us negative 6. And then we'll do 20 minus 12, which will give us 8. And negative 6 over 8 I can simplify to negative 3 over 4. That's the slope. At this point, I want to know what the y-intercept is. Now, you can use b equals y minus m times x, which I think you should do. Does not matter which one of these 2 points you choose, so I'm just going to choose the first one. So b is equal to y minus m times x. Like that. That doesn't look very nice, but that's pretty simple. Actually, we can let the calculator handle this work anyway. Or, you know, honestly, we don't need a calculator for this. What's going to happen is that 12 divided by 4 is going to become 3, and so this is negative 3 times 3. In other words, you get 12 minus negative 9, which is 21. That's what b is, by the way. So put that information together, and your equation is y equals negative 3/4 x plus 21. That's the equation. Just checking that really quick in my head and spot checking it. 12 times negative 3/4 would be negative 9. Negative plus 1. Yep, it's correct. Okay. 397, we're going to graph 2 lines on these axes and find their point of intersection. A very important skill for the upcoming Chapter 4. All you got to do is be able to tell me what the y-intercepts and the slopes are and use those to make the line happen. So for this first line, the y-intercept is 3. I'll put a point right there at 3 on the y-axis. The slope is negative 4, so if I go to the right 1, we'll go down 4. Right 1, down 4. That's how you represent that slope. And once you got a few points, you can go ahead and just put it on the line, and away we go, like this. We are looking for an intersection point later on, so it's important to show as many of those points as we can, because I'm willing to bet the intersection point will be a whole number. Next, we got x minus 7, where the slope is equal to, the y-intercept is negative 7, and the slope is equal to 1. So we'll go ahead and put negative 7 right there on the y-axis. We're going to go over 1, up 1, over 1, up 1. There's our intersection. 1, 1, 1, 1, just like that. So we're right there. That is the point, looks like it's the point 2, negative 5, I think. That's the intersection point. And then 398, we have some exponent rules problems, which are usually pretty easy to deal with here. With question A, we're just multiplying all that together. I know it looks like a distributive property problem, but it's actually not, because there's not a plus right there. So this is just going to be x to the 4th times y to the 3rd. That's all there really is to say about that problem. Question B, we're going to divide here, so we're going to make 3 minus 2 into 1, and 4 minus 3 also into 1. This ends up being x to the 1st, y to the 1st, which we would never write like that. We write it xy. Question C, we have, let's see here. 2 times negative 3 gives us negative 6. And then we'll have x to the 6th power. The 2 plus the 4 gives you the 6. And then finally, we got 2x to the 3rd, which we should never forget is equal to 2x times 2x times 2x, which means 2 times 2 times 2 gives us 8x to the 3rd. There we go. Hope you enjoyed this video. I'll be posting it tomorrow, so you'll be able to see it, and I will see you in the next one. You are awesome.